Okay, so this is our first video for factoring binomials, and we're going to talk about the difference of squares. And one of the things that I want you to notice is that this is going to look really similar, but backwards, of course, to something that we did in the last chapter. And that is, you see that we've got this, as our product, we've got this a minus b, a plus b. And in the last chapter, we talked about this in terms of multiplying these, and we were multiplying a sum and difference. So this is exactly the opposite of that. That was a multiplication process. So again, this is a division process. So let's talk about the steps to get from this to this. So the first thing that we want to do is make sure both of the terms in your binomial are perfect squares. So let's talk about this for just a minute. Now, hopefully for the numbers, that's not so big of a deal, that's so much of a deal for us. But what we do need to remember is that everything has to be a perfect square in both terms. So that means the variables also have to be perfect squares. So we better know how to identify variables with perfect square that are perfect squares. So obviously we know x squared is a perfect square because we know that that is x times x, and there's really, nothing to think about there. But let's talk about something like x to the fourth, maybe x to the sixth, and x to the ninth. Now this is where we have to really sit back and think. We have to think about the fact that we are doing exponents instead of constants or whole numbers. And this is where sometimes we need to focus a little bit more to remember the special things that happen here. So the x squared, x to the fourth, and you may want to stop for a minute and just sort of ponder this and think about which of these three things that I just wrote down here are perfect squares. Pause. Now we're back. All right, so x to the fourth, remember the idea here is x times x gives me x squared, right? So the two things that I'm multiplying together have to look exactly the same. And when we multiply them together, they have to give us our original, obviously, right? So this one, if we multiply x squared times x squared, well, remember going back again to last chapter when we talked about exponents and we had like bases, and when we have like bases, we add the exponents. So 2 plus 2 is 4. So this is a perfect square, x to the fourth. Now, x to the sixth, we're going to skip for a second. How about x to the ninth? Everybody likes x to the ninth because of that 9. Well, again, the idea is that we have to have something that's exactly the same. So we can't do that. Let's say we did x to the fifth times x to the fourth. So x to the fifth times x to the fourth is indeed x to the ninth because 5 plus 4 is 9. But they're not exactly the same. There aren't two numbers that are exactly the same, that are whole numbers that are exactly the same, that are going to add together to get 9. So this is not a perfect square. Now, x to the sixth, which doesn't appear to be a perfect square, is a perfect square because x to the third times x to the third, 3 plus 3, keep the base, add the exponent, so 3 plus 3 is 6. So this is a perfect square. So think about how these two are the same. And the fact of the matter is that we could keep going on this. We could keep doing more. The pattern that we would find is that when the exponents on the variables are even, they're perfect squares. So when the exponents on the variables are even, we know they're perfect squares. As soon as we see that they're not even, like this x to the 9th that we talked about, we know that they're not a perfect square. Now the next step, pretty straightforward. All we have to do once we get our little binomial is we write our double parentheses. And I'm going to do an example of this, talking these steps once we get through the sort of the basics right here. The next thing we do is we take the square root of the first term and put it in the first position of both of those new parentheses. Then we take the square root of the second term and put it in the second position of the new parentheses. And then we just have a plus and a minus. And our last step, always, we want to just FOIL back real quick to make sure that we're right. So here we've got our first example. And this is pretty basic. Hopefully, and again, we need to make sure that we recognize that we've got a perfect square, and we see that x squared, we recognize that quite easily as a perfect square, and of course 4 is a perfect square. Now the other thing when we are doing this is we have to look for the sign in the middle, and that sign in the middle needs to be negative, and we'll go there in just a few minutes why. But the first step we said was to draw the new double parentheses. The next step was to take the square root of the first term. So x squared is the first term, the square root of that is x, and we place that in the first position of our new parens. The next thing that our steps had was we looked at the 4 and we took the square root of that, and obviously that's 2, and we put that square root in the second position of each of our new parentheses. And then our last step was just to put in the plus and the minus. Now people always ask, do you have to put the plus first and the minus second? Absolutely not. I do, and later on it'll become obvious why. It's just a good habit. It's easy. It's easier to make some observations later on is all. But mathematically, it's the same thing. We've got two factors multiplied by each other. Does the order matter? Absolutely not. So we've factored this thing. Now, the next thing that we should always do is FOIL back to check, and that's particularly important right now. So we're going to take the x times x. We see we get x squared. Then we do x times negative 2 to get negative 2x. Then we take positive 2 times x and get positive 2x. And then we get positive 2 times negative 2, and we get negative 4. Now, we always at this point, when we are foiling, we look to see if we can combine like terms. We see that we've got like terms here. They're both x terms. And we see that there's a negative 2x and a positive 2x. Those equal 0. And that's what's left. So we get our original back. So this is how this works. Let's do another example real quick. Let's see. 4x squared minus 81. So let's go ahead and try this thing. So the first thing, of course, that we do is we put our double parens down. The square root of our first term, well, again, we're making sure that everything is. So each factor in each term has to be a perfect square. So 4 is a perfect square, x squared is a perfect square, 81 is a perfect square. So each bit of this is a perfect square, so that's how we know we can do this. So now we look at 4, and we know that the square root of that is 2. The square root of x squared is x. The square root of 81 is 9. We do our plus and our minus, and we're done. And then, of course, the last step that you're going to do is just to FOIL it back real quick to make sure that you are correct. And I'm going to do that not every single time, but I'm going to do it one more time just to make sure that you're thinking this way, and I really want you to do it. So 2x squared times 2x, 2x times 2x is 4x squared. And then we have 2x times -9, and that's -18x. Then we go to this one, which is +9 times 2x, and get +18x. And then we do our our +9 times our -9 to get -81. Our middle terms once again cancel out. And there we are with our original. So now we're going to look at the sum of squares. And the sum of squares is really special. I want to go back and remember, this is all about doing the double parentheses. So when I teach this in class, I usually ask people for thoughts and ideas. And of course, we always get the x and the x. And of course, we've got to do the 3 and the 3. So the question is, what do we do with the signs to get a positive? Well, if you go back to your integer rules and you say, all right, well, integer rule says it has to be the same sign, right? So let's put in pluses there. And now we're going to multiply this back. So x times x is x squared. X times 3 is 3x. So we're doing our FOIL here. 3 times x is, again, 3x. And then 3 times 3 is 9. Then we combine like terms, but we see we end up with a middle term here. So that can't be correct. So the next thing that people usually want to try is doing the minus. So let's go ahead and put the minus in there. So again, we do the same thing. We're going to multiply. I'm going to FOIL it out. I'm not going to show all the arrows this time because I just want to get through it a little bit more quickly. So x squared, -3x. Then we start looking at the -3 times x, -3x. Negative times negative is positive. Combine like terms. Again, and I added that wrong. That's horrifying. There we go. We add again the middle terms, and we end up with a middle term again. Well, so this is an enigma for us right now. We're not sure what to do. Well, the truth of the matter is there's no way to do this. So no matter what combination of signs we put in there, it's not going to give us a binomial that has a positive between them. If, again, we put in the plus and the minus, we'd be back to the difference of squares, and that's what we would be factoring. So the truth of the matter is that this little guide, a sum of squares, is special, and we remember that it's not factorable. You can write down prime, or you can write not factorable. That doesn't mean that there's nothing we can do with it, by the way. It just means that we can't factor it. Later on in the next class, you're going to do some more interesting things with this.